So we learned how to multiply and we learned how to divide rational expressions. And the point of this section is to get a little more practice doing so and be able to identify which is which, because if we can't do that, we won't know what to do. So for example A, our directions are multiply or divide as indicated. So what's the indication here? The dot means to multiply. So that's how we know this is multiplication. And we're going to do the multiplication here straight across. If you have more than one term, make sure you lock that up. So x plus 3 times 7 in the numerators and x times x plus 3 in the denominators. And then, I could rearrange the factors here, where I could just divide x plus 3 between the numerator and denominator. And so that leaves me in the numerator 7 and in the denominator x, and that's our simplified product. Example B, which of these are we going to do? If you look at the sign here, that's the division sign. So we're going to divide, which means multiply by the reciprocal. So I'm going to leave the first rational expression the same, change division to multiplication, and then flip the denominator and numerator of the divided rational expression. So then I'm going to multiply across. So in the numerators, x plus 3, and in the denominator, x times 7. And this is kind of a trick, because if you saw this, you might try to say, oh, let me divide these. And that's a mistake that is made if you don't multiply by the reciprocal first. So be careful with that. Well, do we have any factor in the numerator that's also in the denominator? No. So we're going to multiply this out. That's x squared plus 3x plus 3x, so plus 6x's altogether, plus 9. And in the denominator, 7 times x. So that's our simplified quotient there. In example C, we've got that divide symbol again, so we're going to multiply by the reciprocal first thing. So leave the first rational expression the same, change division to multiplication, and then let's flip the denominator with the numerator. Okay, and then we're going to multiply, so lock up any factors that have more than one term. So in the numerator, we have an x plus 2 and an x squared minus 9x plus 14 factor. In the denominator, we have a 7 minus x, and I don't like that, so let me just rearrange it first thing. Make that a negative x plus 7 and x squared minus 5x plus 6. I like my polynomials to be in descending order. That just makes it easier to work with. And then our next step is to factor completely the numerator and denominator. So the first factor, x plus 2, is already done. Can't be factored any further. The second factor, though, there's no GCF for this trinomial, so that means we're going to be unfoiling this trinomial. Factors of the first and last term, and the sum has to be the middle term. So x squared is x times x. I know that those are going to be the first terms of those factors. But then 14 could be 7 times 2. If we have the same sign, they're both negative, so yep, that adds up. So we have an x minus 2 and an x minus 7 if we go across there. Now let's look at the denominator. Our first factor, there's a negative, so that means we must factor out a negative 1. So negative 1 there. And divide, so it's going to change those signs to a positive x and a negative 7. And then the next factor is a trinomial. There's no common factors, so we're looking for factors of x squared and 6. That adds up to negative 5x. Let's try 3 times 2 this time, because I know these are the same sign. They're both negative, and that's the only way that's going to work. So we have an x minus 2 and an x minus 3 factor there. Awesome. Everything is completely factored. Let's go ahead and divide factors, so we can cancel an x minus 2 and an x minus 7. Let's see what is left for us in the numerator. An x plus 2. That's it. And in the denominator, a negative x minus 3. And then I can just go ahead and distribute that negative to simplify that. So it'll be a minus x plus 3 altogether. And that is our simplified quotient.